At Claranor, we have developed sterilization solutions for various industrial applications, particularly closures and caps. The main contamination hazard for a bottled product comes from the cap. The shape of caps and closures becomes more and more complex so that their microbiological safety can be tricky. For example, sports caps regularly used for soft drink capping are difficult to sterilize with chemicals because the thread segment contains areas in which chemicals can get trapped. As we explained before, closure sterilization is also an issue for sensitive products such as soft drinks with a low rate of preservatives, flavored and purified waters, fresh milk, and other dairy products like drinking yogurt. The solutions developed by Claranor treat the entire internal surface of the cap thanks to the power of the pulse light flashes and their reflections. Another application for which pulse light is an ideal solution is preformed cups, especially those that are meant to contain refrigerated dairy or low-acid products. For instance, the cups used to package dairy products are not manufactured at the production plant. They are transported in. This means there is a break in the hygienic chain that can permit contamination, especially from molds. Pulse light efficiently treats the inside of caps of various shapes and depths. In the near future, we will be able to deliver equipment for aseptic packaging for applications such as internal or external sterilization of closures, caps, seals, and bottles. These applications are currently under development. Why use pulse light? Let's take a closer look at the assets of the technology.
First of all, because of its performance. Pulse light outperforms continuous UV regarding microbiological decontamination and equals the efficiency of chemical treatments on many products. Pulse light treatment can be reproduced and traced very easily. Each product receives exactly the same amount of energy. The procedure is monitored and can be checked at any time. Contamination reduction levels of 3, 4, and 5 log can be reached for ultra-clean and ESL applications, complying with industrial requirements. On this slide, you have an overview of the validation report on sports caps realized by the Fraunhofer Institute in Germany. This independent laboratory validates every new application from the decontamination level point of view. We can provide those reports for all applications on request.
Pulse light is more cost-effective to run and uses very little space. Because of the pure sterilization method, you gain with respect to effluent disposal, water, and chemicals. The equipment is completely servo-controlled by the line. Plus, the equipment is easily cleaned and disinfected. Because of the high availability rates of pulse light technology, there is no loss of time for heating or starting the process. The technology reaches its nominal efficiency from the first flash. So, when the line has stopped or slowed, there is no problem restarting. With pulse light, what you see is what you get. No extra costs for transportation, no storage, no maintenance. The light is all there is. So, running costs are limited to lamp change and energy consumption. The best way to illustrate this is to show examples of costs both for industrial closure and cup treatment units. The capex for a cap sterilizer is in the range of €50,000 for an ESL application for flat caps. This equipment allows treating up to 72,000 caps per hour. Running costs involve only lamp and energy. For both caps and closures, the total operating costs with pulse light are less than the cost of chemicals in a conventional treatment.
On top of these benefits, working with pulse light is much more environmentally friendly. The energy consumption for running the pulse light unit is insignificant compared to the all-line consumption. Plus, it uses no water, no chemicals, and therefore has no chemical residue.
Now, a short illustration of Claranor pulse light application in the industry. Rouiba is a leading Algerian manufacturer of juices packaged in cartons. In 2009, the company installed a new PET line for fruit-based beverages. The filling technology in the PET line was based on cold, ultra-clean filling. But how to avoid mold hazard when the product has hardly any preservatives? Initially, Rouiba installed continuous UV on the new line, but results were not satisfactory. Eventually, Rouiba switched to pulsed light for 3 reasons. The solution delivers the required decontamination level for molds, especially Niger, at the production rate of 12,000 bottles per hour. The unit uses no chemicals, and because of its compact design, the pulsed light unit is easy to integrate in the existing line. Pulsed light should have been the standard in sterilization a long time ago. However, it appeared to be a challenge to bring microbiological knowledge and light technology excellence together. After years of development, Claranor brought pulsed light technology to a performance level that meets industry standards. And now, we take the next step. We brought our microbiology experts together with experts in the field of high-tech machinery and scientists. With our team and partners, we are developing a new norm in the industry. This new norm has a name, Claranor. If you want to lead as an eco-responsible manufacturer and improve on your cost performance, integrate Claranor in your packaging line. You will be setting a new standard. Give a profound signal to your customers and competitors and improve your performance. These companies already sterilized by the new norm. Thank you very much for your attention. I hope this webinar has given you the insight you hoped to get. And if you want to discuss pulsed light in depth, Caroline, Xavier, and I will be available now to help you find answers to your sterilization challenges. Thank you for listening.